Thank you. Hello and welcome. Nice to see you today. Today we'll talk about cost cutting in the cloud. We'll talk with my co-hosts, Maciek, Roman, and as we mentioned, another Maciek is unavailable today, but we'll cover for him. So maybe let's start with a simple question. Was anyone here ever surprised by a bill from the cloud? Okay, in a good or in a bad way? It was higher than you anticipated or lower? Higher, okay. That's the usual case. So we are here to tell you how to prevent it from happening or maybe lower the cost in the future. Our presentation is split into 3 parts. We'll start with what is Ocado, OSP and OTP, and cost visibility, ownership, and finding cost savings. Also, we'll look at services behind our Ocado Technology platform. In part 2, we'll look into reducing costs of networking and runtime. In part 3, we'll go over edge reducing costs and observability costs. We'll finish up with summary and some questions. So let's begin with who we are. Ocado is a well-known grocery store in the United Kingdom. And Ocado Technology is a company which enables Ocado from technical side. We create automation they use. So more about Ocado Technology itself. We are global leader in AI, robotics, and automation. We have wonderful tech specialists all around the world. And we have 13 global retailer partners. But I think you may not know us actually locally. Anyone shopping at Auchan? Okay. Offline, online?
Online.
Okay. So those who do online shopping, you use our technology. Since 2022, we have agreement with Auchan Retail, and they use our automation to help with their retail processes. So I basically talked about who we are, but I didn't tell you about our products. One of our main products is Ocado Smart Platform. It's a business product, so it contains of 4 elements: e-commerce, supply chain, fulfillment, and last mile. Okay, this is business part. And this business part contains of applications. And applications needs to run somewhere. And this somewhere is a cloud platform we created. We call it Ocado Technology Platform. More details about this platform, why we created it, what it's for. We have many wonderful developers, but they don't care about deployment, application configuration, AWS accounts. They just want to work fast and have self-service. So basically they write an application and they just know it that they want to deploy to retailer A, warehouse C, and they want to deploy either to cloud or to the edge. And that's all they want to know. They use self-service, we created for them, and this enables them to work faster. Okay, so we have the platform. We have also 13 global partners, retailer partners. What does it actually mean? It means that the platform needs to be available all the time and everywhere. It needs to be global. And this causes this platform to be huge. Almost 2,000 developers are using our platform, cloud platform. We have over 80 AWS accounts and almost 150 ECS clusters. And ECS is only one technology. We used more than one. Our biggest ECS clusters consist of 400 VMs, 900 services, and ECS service, for those who don't use ECS, it's like Kubernetes deployment. Those services start around 2,000 ECS tasks. ECS task, let's compare it to Kubernetes pods. And this is only the cloud part. There is also the edge. And the edge, we have a lot of it. we have hundreds of devices per warehouse. So actually, what does it mean? It means that even a small cost reduction is multiplied a lot. Okay, now let's move to FinOps, and I will pass mic to Roman.
Thank you, Kasia, for the introduction. Okay, so I'm going to talk to you about the FinOps best practices. So in this chapter, what I'm going to lay down is don't do that with cost saving. So it's basically to lay the foundation for the next chapters, and it's about getting the best practices right. So I have 5 tips. Some of them might sound trivial, but the first one is about the tagging. So what we figure out is that at least you should start with an application identifier tag that you will put on all of the resources that your application uses. And you will find out that for services which AWS just shortly introduced, the tagging might not yet be available. And in that case, you can always use the single naming convention, and that way you will be able to figure out the name of the application from the name of the resource. What we've learned the hard way is that you should keep it simple. So on the left, you can actually see how our old tagging policy looked like. So you see multiple different key value pairs. I think this is for DynamoDB. And you will see that some of them, they are actually duplicates. And the worst mistake we've made so far with the tagging probably is that we try to replicate our organizational structure within the tags. So in here, you see that we have the team ID, but with every new director coming, changing it a little bit, and teams passing the projects, it keeps on changing. So it's actually much better to do what we do right now and just introduce a single app ID tag. And if you need some additional info, you can always abstract that away, for example, to some additional lookup service. The key benefits of using tags is it will help you to identify the accountability. So who is responsible for certain billing items. Okay, so the tip number 2. If you are in here, you are probably working for organizations which manage more than a single AWS account. You have more than one. So in that case, I would encourage you to look at the AWS organization and tie them all together to a single root account. So the key benefits of that would include that we will later on tell you more about some prepaid services. And if you pay for them on that single central account, it will go down the tree. So it's much easier. It's also a single place to see all of your invoices. And it offers you a centralized cost explorer, a graphical tool I'll show you in a bit. Tip number 3 is about enabling something called AWS Cost and Usage Report, which is CUR in short. And what that is, it's kind of like a CSV file, usually quite a huge one, that AWS will put in your S3 bucket, and it will contain all the billing line items with all the costs that you occurred throughout that day. So this is an example of that, just a couple fields. In our case, it's probably something like 40 plus fields, but you will have at least payer account ID, so basically the root account ID. You will have the line item usage account, so where the actual cost occurred. And you will have the name of the product, Lambda. You will have some description regarding what you've been charged for. You will have the resource ID, so basically an ARN. And if you introduce tagging, you will see tags in here as well with the costs, obviously. So those costs, they will come in form of blended and unblended costs. Some of them will be before savings, some will be after. So the key benefits of using cost and usage report is that it gives you possibility to analyze data in a way AWS did not think about. And it's a great starting place for custom dashboards. Now, speaking about the dashboard, I would advise you to familiarize yourself with the Cost Explorer, which is actually built into AWS. And it's a nice graphical tool which will tell you where you are spending your money. So, for example, in here you see that in Ocado, throughout the duration of from February to April 2025, we've bring down all of the costs based on the tagging, actually the app ID tag. So you see which application is the most expensive one. And there is many options in which you can group that data or filter it out. And the key benefits of using it is that it gives you visibility, and together with nice tagging policy, it will also give you accountability. And it's a great place to look for cost savings. Now, I'm going to flip the script a little bit in here, because throughout the duration of this presentation, we are not allowed to share with you any actual numbers, how much we spent, but I'm still going to be a hypocrite and ask you guys, raise your hand if you work for a company which spends at least $250,000, so $250K per year. Okay, I see some hands. How many of you people have heard about private pricing agreement, previously called enterprise discount program? Okay, I think two people, 3 people. Okay, so this is what it is. It's kind of like an agreement you can reach with AWS. It will probably require signing some papers, and you agree to pay a certain amount of money every single year spent on AWS, and they will give you some nice savings. The more you declare, the more the commitment is, the more savings you will get, typically between 5 and 20%. And those discounts are applied for almost all services in all regions. And even better, those will stack together with some other discounts. So, for example, if you are paying for spot instances, you will still get EDPs applied, PPM is now the name, applied on top of that. And it's just an easy win. You just need to sign off some papers. But be aware that this PPA is a double-edged sword. So let's look at this example. Let's say you've signed a contract with them. Typically it's going to be 3 years contract. And you said, I'm going to commit to spend on you guys 3 million every single year from 2026 to 2028. So in total, you are going to spend 9 million. Those individual years, they don't matter that much. The last one is the one that matters. So let's look at this example. And in the first year, 2026, you've spent 4 million, which is actually 1 million surplus. In the second year, you are on par, 3 million. And in the third year, you've spent 2 million. So you are 1 million short. But in total, you actually reach your commitment, everything is fine, and you got those nice savings applied. Now, what will happen if you will go under that? Let's say instead of spending 9 million, you only spend 8 million. The AWS is going to go back to you guys and ask you to give them that million back. There are some ways how you can actually avoid paying them. Like you can, at the end of the contract, week before, prepare for some services, buy yourself to the thief. But you should be aware of that. Right. So those were the tips, FinOps one-on-one, let's say. And now I'm going to tell you more about the framework that we've been working on inside Ocado Technology. And we use that to spot the best cost-saving opportunities and also to introduce them as fast as possible. Okay, so before that, I wanted to ask you a question. How many of you came here with some ideas about some things you want to introduce to save money in your company? Please raise your hand. 2, 3, 5. Okay, yeah. So I'm here to tell you that you should follow your instincts because you are probably right. Especially if you've been long enough with the company, you know where all the bodies are hidden, you know all the closets, you know the architecture in and out, and basically you have the pretty good idea where to start looking for savings. But I wouldn't be an engineer if I haven't followed it with validating it with the actual data. So speaking about the data, I wanted to share our journey when it comes to financial data. So a couple years ago, what we had was, we had AWS for the runtime. We had second cloud, GCP, for the data lake. We have many paid third-party tools for observability. And it just was like a lot of different data sources. So if you wanted to figure out how much your particular service application cost, you would have to go to many people, ask them to pull off some data. It was very messy. What happened throughout those years, we introduced yet another cloud, Azure, for authentication. So it's even more complicated. So basically, then there was a new team created actually here in Krakow called Skynet, and they had a mission to improve this situation. So basically, they were formed to build a single source of truth for all of those resources, and they were also asked to provide some graphical representation for that. So enter the FinOps dashboard. This is the result of that. This is an internal tool that we have. As you can see in here, we split those costs in three main categories. So basically AWS, GCP, third-party apps, and you can see how much we spent on any of those throughout April and end of March. And we also have due to tagging policy, we actually have the ability to group those by the organizational structure. So group it by the stream, department, individual teams. Teams can pick individual application and look how much does it cost. And it's actually also a part of Ocado culture and part of maturity model for teams to look at least once a month and check whether they are not overspending. Okay, so and that FinOps dashboard is also a great place to start looking for the savings. So speaking about the savings, how you do that? What we've learned, there are a couple vectors of attack you could take looking at that. So the first one is the looking for the top spenders. So as you see in here, I've just grouped it by the top spender on the logging category. And you see that there is a couple applications, 5 applications, and in total they amounted for more than half of all the logging costs. And this particular pattern keeps on reappearing wherever we actually look. So there is kind of like a Pareto principle going on, that you have a handful of services, applications, and they are responsible for most of the cost. And I think it's true for any company, really. Now, what is that 15% for e-com slots actually a lot or not? I would say it's hard to tell, because those guys, they might have a very good reason for logging so much. Maybe they have a lot of traffic, important mission. So what you should definitely avoid is going to those product teams and start with being judgmental. That won't work well. You can probably still go to them and prod them a little bit, ask them whether they are happy, ask them whether they know that they are on the top of the list. So that would give them food for thought. Okay, so the next one, next vector of attack is looking for the most expensive services. So in my mind, I think about it as kind of like peeling the layers of onions. So you kind of like have this giant onion, your AWS spend, and you try to go down, peel off all the layers and figure out where you can save money. So you see the cost explorer, and I've actually grouped it by the service, and it's from February 2025. And you can see that on the top we have the EC2 instances. Maciek is going to tell you more about how to save there. I'm not going to steal his material. Next one is the tags. So as engineers, we can't do much with that. The third option is vaguely sounding EC2 other, what it really means, it's mostly AWS storage and networking. So let's focus on storage in here. If I'll notice that storage costs us a lot, I will start asking questions. Those questions will be something like, what kind of storage classes are we using? Can we do some migration from GP2 to GP3 in order to save some money? And maybe we are keeping a lot of snapshot for the volumes. Maybe we don't need so many. I don't know, maybe God forbid, we are deleting EC2 instances, but we are forgetting about terminating the volumes of the deleted instances. So I'm kind of like going to look at all those different things, and I'm going to write down what I found. So what we are really doing in here is we try to follow the odd one. So this is kind of like a game you've been playing since your early childhood, where you have like two pictures and some things don't match, like find 5 differences, things like that. And the most basic odd one you will notice is something like this. So you had what we are looking at is S3 simple storage. It's basically in the Europe, and we are looking at the cost of the put object operation. So it was fairly stable until the September, and then in October something happened, and you see that giant cost spike. And you need to investigate that basically to figure out whether it's good or not. So in that particular case, you can, for example, enable additional S3 server-side logs to figure out who generated those extra calls. But finding an odd one can take a different shape or form. And finding an odd one could be you realizing that you've provisioned all of those KMS keys because you wanted to be super secure a couple of years ago, yet most of it you don't use at all. So that was actually the case for us, something we are still cleaning up. So out of all of the KMS keys, how the pricing works, you pay flat price $1 per year, and if you enabled KMS key rotation, you will pay for those older keys up to year 3. So this is not much, but at scale, it's actually quite a lot. So in here, for example, we've noticed that 26% of all of those keys are never used, and we can just delete them, no one will complain. We figured it out looking at the CloudTrail logs. The additional 57% are used, but when we checked what they are used for is S3 KMS server-side encryption, and we've been doing that for historical reason. And I think 2020 was the year when AWS introduced S3 server-side encryption for free. So we could just like re-encrypt everything and get rid of all of that stuff, leaving us with only 70% of the original amount. Right. So yeah, you went through all of those things, you find some ideas, so it's time to introduce them. And actually before that, you need to figure out which one of those ideas you should follow. So in here, this is a snapshot I took this morning from our internal system, and we've been tracking our progress when it comes to cost savings, and this is an accumulative graph. It goes up with the more savings we introduce. And basically we started tracking that in early September, and what you see in here is that at the very beginning of this period, it's kind of like a flat line because we are still learning our ropes. We are trying to figure out what are the best things we should do next, and so on. Then we hit this golden period. Like you see that sudden growth until something like, I don't know, like mid-January. So that's when we started noticing a lot of low-hanging, very juicy fruits up for grabs. And we started picking them. So for example, one of those biggest ones in here, I think this one, was actually 3 lines of codes which contributed to like a lot of saving, and Maciek is going to tell you about those 3 lines of code. So it's very nice to very cool to be in this period because you keep on introducing new cost savings. What we've learned is that eventually it's getting harder and harder and harder and kind of like flatlining. So this looks like an S curve. This doesn't mean that there are no more cost-saving opportunities. It just means that it's basically it takes more time to introduce those another one. So we can easily double that, but it will cost us lengthy migration. So things you should consider when you will be picking your cost-saving ideas. Is the effort worth the payback? So actually, how much work is required to deliver something? And does the work require doing any longer migration, maybe going to many product teams, asking them to modify their code? Like in that case, it's going to take a bit of time. And can you actually do some of the stuff centrally for them without even asking them? That will be much faster. And I think as developers, especially in Polish IT, we keep on committing this cardinal sin of ours, undervaluing the time and actually that the human factor is the most expensive in the IT companies, sad but true. And basically, the quote from the internal Google research, the value of human time at most software companies is 20 to 100 times the value of machine time, which basically means that if you engage in a cost-saving initiatives that will take months, you will contribute to net loss for that company. Okay, so you have some cost savings that you've picked already. What to do next? How to introduce that? So first, I would calculate the actual cost saving. This is not that hard most of the time because AWS, any cloud actually gives you price listings on their sites, so it's not hard to do the math. Next, I would write it down in all those findings in a single document. And I would slap a nice label at the beginning of that telling it will save us, I don't know, like 100K next year, because you are selling it a little bit to the folks. I would definitely explain the consequences. So for example, if you are going to replace one service with another, does it going to bring the performance down? Like people have to be aware of those trade-offs to make the decision. I would obviously do the peer review of your findings and also the maths. And I would make sure that the decision makers read it. So yeah, and 2025 is just basically a great climate for savings because interest rates are quite high. It's harder for companies to obtain money from the market. And some countries are trying to make them tariffs great again. And it's basically easier to convince people. And people do understand money. And your manager might not understand what NAT Gateway is, what it does, but he will goddamn well understand that by replacing it with open source alternative, you are going to save company like $1 million next year. And with that, I'm going to pass the mic to Maciek, who is going to tell you more about our architecture. Thanks.
Thank you, Roman. Please bear with me for just 2 minutes before our first short break for today. And now we're going to take a look at the services behind Ocado Technology platform. So this is a high-level view of our architecture. It obviously does not contain all the services that we use, but it should guide you through our presentation today. So the access layer for us consists of CDN in the form of CloudFront, as well as Web Application Firewall. For some applications, we use API Gateway. In all our accounts, we do have VPC, obviously, with Internet Gateway and NAT Gateway. And for cross-account communication, we use AWS Private Link. Inside the VPC, we use application load balancers as well as network load balancers. And behind them, we have a fleet of Nginx proxies. Then our runtime, it mostly consists of ECS clusters with both EC2 instances and AWS Fargate, so serverless containers. For inter-service communication, we use SNS, SQS, as well as Kinesis streams. We have observability in CloudWatch, S3 Athena, as well as Prometheus and Grafana. For data, we use RDS, S3, and DynamoDB as well. But that's just the cloud part. If we also think about the edge, so the computers that reside in our warehouses, we are using both ECS Anywhere as well as AWS Greengrass IoT. I hope you had a good look at our architecture. Now we're going to deep dive into particular elements of this architecture. So let's start with the networking section. What can be done here? Let's first take a look at the CDN layer. The first thing that I want to mention when it comes to CloudFront, CloudFront is priced based on the number of requests that are passing through CloudFront, as well as the amount of data that CloudFront serves. And first option that you have to save money with CloudFront without the need of reducing neither the amount of requests or amount of data that is exchanged are CloudFront security savings bundles. And if you take a look at this chart, you can see that in December, something red popped up in the chart. And that was the moment when we bought some of the CloudFront security bundles. At the same time, if you take a look at the other chart, which shows the traffic, so the number of requests passing through our CloudFronts, you can see that it's, it differs a bit month to month. But in general, the cost saving related to the security bundle is much higher. So if you commit to a 1-year spend on CloudFront, you can save up to 30% of your money on CloudFront and 10% on Web Application Firewall. But again, as Roman previously mentions, commitment is a two-edged sword. So you can save the money, but if you overcommit, well, then you're going to have to pay what you committed for. Another aspect when it comes to CloudFront are price classes. But before we dive into price classes, let's talk how CloudFront works. Whenever a user makes a request to our infrastructure that utilizes CloudFront, the request is served from the closest edge location to that particular user. And price classes determine which edge locations can be used to deliver content, and that influences both the cost and performance. So let's take a look at price class 100. Well, if you have your users in Europe or in America, you can use price class 100. And only the points of presence in those two areas will be available for CloudFront to serve the traffic. Now, if you have users in more remote locations, you can upgrade for price class 200, which also includes Asia and Africa. And the way that CloudFront pricing works is you are being charged based on the location from where the traffic is served from. So if you enable price class 200 and your users reside in Asia, you're going to pay for the traffic served to those Asian users from the Asian edge location. But if your users are also located in the US, for the US users, you're going to pay for the edge location based in US. Last but not least, there is price class all that includes all the whole world and all edge locations of Amazon. And then again, you are being charged based on where your users reside. Now, here's a comparison of all those price classes. And the important factor here is that by default, when you set up your CloudFront distribution, AWS sets you up for the all price class. So make sure to use the correct one based on where your users reside. All right, next aspect, it might sound obvious, but compression. If you can serve 5 kilobytes for your document, which is zipped or uses Broadly compression instead of 50 kilobytes, well, that's almost 10 times less, right? And remember, in CloudFront, you are being charged per the amount of data transferred as well. So don't forget to enable compression whenever that's possible. Again, the whole purpose of CDN is to deliver the content to your users as fast as possible. And the mechanism that supports that is caching. So whenever a request is made towards CloudFront, as long as the content is cached and the cache is still valid, it is served from that edge location. If the cache has expired or it's not present in the edge location, then it has to go to your origin, which is either a S3 bucket or an instance. So remember to cache everything that actually can be cached. And an important aspect here is that if you are able to cache more of the content, you are not also improving the latency by decreasing it, but you're also lowering the load on your instances behind. So you're also saving on compute. Who has heard of Lambda at Edge? Right? One person? Yeah, something like that. CloudFront gives you a possibility of executing Lambda, so a serverless piece of code, whenever a request reaches the distribution. That's fine. But what people often forget about is that by default, the execution role, the IAM role that's used by this Lambda at Edge, it's configured to allow pushing logs to CloudWatch. And if that Lambda is executed on every request that reaches your CloudFront, that can generate a pretty substantial amount of logs. What can we do about it? Well, we can simply provide the IAM policy that denies the put log events or create log group actions to protect it from not pushing the logs to CloudWatch. Of course, if that's not necessary in your case. The next point is combining CloudFront with API Gateway. If you're using a setup where you're putting CloudFront in front of the API Gateway regional endpoint, you are being charged for HTTPS requests, so fetches from origin, even though it's still AWS network only. So what can we do about it? Well, AWS introduced the API Gateway Edge type of endpoint, which includes CloudFront underneath. So you don't need to provide additional CloudFront distribution in front of the API Gateway anymore. And by that, you are reducing the amount of money you spend on the request count. So it's a nice one, and it can save you money instantly without sacrificing anything. And last but not least, when it comes to CloudFront, let's talk about internet bots. Right now, bots contribute up to 50% of total internet traffic. That's quite a lot. And if you can investigate bot traffic patterns, looking through your CloudFront or web application firewall logs, or even app telemetry, you can decide what actions should be taken for those bots. Some of them might be legitimate, like search engine optimization bots. But some of them might be scraping your websites to get data to fill the AI models with, right? So you can take then actions to either throttle those specific bots or even block them. And in case of search engine optimizations, you might think of serving a lightweight or cached version specifically to some particular bots. All right. So that's it when it comes to CloudFront. The next part is the ingress. So what happens when the traffic reaches our VPC and has to be routed to the particular application? All right. So API Gateway requires a strict VPC link and NLB integration. If you take a look at the constant cost incurred by that solution, that gives you around $38 for each of the applications. I hope you remember when Kasia was speaking about the size of our platform. We do have a lot of applications. If we had to pay $38 for each of them just to have the network connectivity, that could have killed us. So we thought of a solution to that problem. And what we're using is a reverse proxy inside the VPC, inside the private subnet, that uses just a single pair of VPC link and network load balancer per the account. But that solution was not ideal at first. At some point in time, we ended up with 36,000 individual Nginx configuration files and a poor performance. I don't know if you like it or not, but for me, working with 36 individual configuration files sounds a bit like a nightmare. So at some point in time, we started thinking, how can we improve that? And thanks to the usage of regular expression and some smart functions inside the Nginx configuration, we were able to reduce the number of configuration files to just 6. And yes, those numbers are correct, 36,000 just to 6 individual files. But after that, we were still observing performance issues. At first, we thought that maybe we introduced performance degradation by forcing the Nginx to compute the regular expressions. So we thought of a kind of prefetching solution that whenever a first request would come to a platform, we would then generate a static config so that all the subsequent requests would use that static config instead of having to go through the regular expression evaluation. But that didn't help. So we rolled back the solution at some test environment. So we fall back to just the static files, and we still noticed that the performance is not great. At that point, well, we doubled the forces and started deep VPC link, network load balancer, and Nginx investigation. And we found out the root cause was TCP. One incorrect setting of keep alive timeout caused us to deplete the number of open sockets. And after we have implemented the fix, we have noticed 80% cost reduction on those proxies and 10% better response times. So sometimes the technical aspects might really influence how your cost look like. That was a big win. The other aspect related to the ingress is related to application load balancers. So the load balancers are obviously needed to route traffic across service instances. And in our previous setup, we used a per application load balancer. And a single load balancer, application load balancer, cost around $20 per month, not counting the traffic, just for the fact that it's set up. So we thought, well, why can't we share the application load balancers? And so we did. We implemented L7 routing on our shared ALBs, and that has allowed us to save 56% on the cost of running our applications. There's one caveat here. The LCU calculations are not that simple. We ended up with about 20 applications per a single load balancer. If anybody here knows how to calculate those LCUs better, please let me know after the session or in the break. But this is quite a pain point. Last but not least, cross-account communication. The question is, how can we provision secure, cheap, and fast service-to-service communication across AWS accounts? When you ask that question, there are two major answers to this one. The first one is private link and a network load balancer, which costs around $32 per a single service, plus the cost of transfer. And the second option is a newer service from AWS called VPC Lattice, which works kind of in a service mesh way and costs $20 per service, plus the cost of transfer. So if you're looking at those two, well, the answer seems obvious, right? VPC Lattice is cheaper. Well, not necessarily. if you take a look at this example and compare it with the one that I shared previously, the setup of VPC private links and API gateway VPC links, these are quite similar. So we thought, why can't we reuse some of our existing infrastructure to provide this additional functionality at no additional costs? And this is exactly what we did. Thanks to reusing part of our API gateway setup and configuring VPC private links to use the same setup, we've been able to achieve that with almost no additional cost. All right. The last section regarding networking is egress traffic. So basically anything that goes out of AWS accounts to the internet. The egress traffic can be both services outside the AWS account. For example, whenever your EC2 instance needs to download some patches, libraries, things like that. Or whenever some services within your infrastructure go and talk to other services, like, for example, S3, SNS, SQS, and others. And if you look at the regular pricing of NAT Gateway, you pay 4.8 cents per gigabyte of traffic. Can that number be lowered? Yes, it can. There is a feature in AWS called VPC endpoints. What are those? VPC endpoints cover traffic to major AWS services as well as third-party services like the one I just mentioned or Grafana. And the traffic resides within the AWS network. It never reaches through NAT Gateway through the internet. It stays within AWS infrastructure. Enabling VPC endpoints is not a replacement for NAT Gateway. It's an additional cost, hourly cost that you incur, but the benefit is that your traffic stays within the network and you incur lower per gigabyte costs of data. So there is a certain level, a break-even level, where if you exchange any amount of data over that point, it's beneficial for you to enable the VPC endpoint for a given service, and you're going to save money with that. Of course, the cost of VPC endpoint depends on the region and the volume of data that is being exchanged. But in general, it generates instant savings. Once you enable that and you are over the threshold for breaking even, VPC endpoints provide instant savings. And that being said, this is the end of the networking part. So now let's take a look at the runtime cost reductions. And when I speak about runtime, I already told you we're using ECS for that. When ECS was introduced at Ocado, that was our third iteration of OTP or of a runtime platform, following the first one, which was on-prem, the second one was Beanstalk, so VMs, and the third one, ECS, it's containers. And for that, we use EC2 and Fargate, so the serverless approach. So the first question is, when should you choose EC2 and when should you choose Fargate? And the first aspect is utilization and scale. So if you're running a single container, or if you want to run 2 or 3 containers, don't bother with EC2s. You should use EC2s only when you reach certain utilization level and scale, because that's when they are most beneficial. Another aspect is the specific instance requirements. So for example, if your workloads require GPU, then you're stuck with EC2. With Fargate, which is a serverless version, you don't have any influence over the underlying platform. The only thing that you can specify is the number of vCPUs that you want to allocate to your containers and the amount of memory. The next aspect, when it comes to choice between EC2 and Fargate, is the level of control and flexibility that you require. With Fargate, you don't have any option to SSH to the underlying instance. It's a serverless approach. It gives you more flexibility, but at the cost of losing some of the controls over your machines. Yet another aspect is resources limits. When Fargate was introduced in 2017, the maximum option that you had was for your task to run with 4 vCPUs. There was also a certain level of memory that you could assign based on the amount of vCPUs that you use. Right now, you can configure your task to run with as many as 16 vCPUs, but then if you want to go any higher over that, and we do, you are stuck with EC2s. Another aspect is that with Fargate, you are always bound to hard limits. So once you go over the allotted threshold, you are going to get, for example, the out-of-memory error. You cannot reach over those limits, whereas in EC2, you can configure the limits to be soft. Last but not least, the management and maintenance overhead. If you're using EC2, you have to take care of those EC2s. You have to take care of the operating system patches, libraries patches, things like that. With Fargate, AWS takes care of that for you. So I said that we're using both EC2 and Fargate-based clusters, but for now, let's stick to the EC2 clusters that contribute towards the most of our infrastructure. And let's take an example here. Let's assume that we want to run a single virtual machine with 2 vCPUs and 4 GB of RAM. In Ireland, it's going to cost you 9.5 cents per hour. Is that a lot or not? Anybody?
It depends.
It depends. That's a good answer. Well, there's 8,760 hours in a single year. So if you want to run that single instance for a year, that's going to cost you $841 for a year, for a single instance with 2 vCPUs and 4 gigs of memory. I don't know how about you, but for me, that's quite a lot. And that's when you're using on-demand purchase option with EC2s. So basically, you pay as you go. You do not commit to anything. You can cancel your instance anytime. But if you use your instance for this 1-year period of time, that's what you're going to pay. So what options do we have to save some money on that? The first option is to use compute savings plans. So this is the option for you to commit to a certain dollar spent per hour. So for example, you tell AWS, I'm going to use $100 worth of compute every hour for the next year. You have the option to pay upfront, to not pay upfront, or pay some certain amount of money upfront. And based on that, AWS is going to give you a discount. The advertised discount is up to 66%, but what we usually observe over a period of 1 year and no upfront payment, this is more about 15 to 29%. But be careful. Again, as with every other commitment, if you commit to certain spend and you do not use that amount of money, well, you're going to pay AWS what you committed to. Another options is EC2 savings plan. With EC2 savings plan, this covers only the EC2 spend, and you're committing that you're going to use a certain instance family, for example, M5, in a certain region. The rest is the same as with savings plans. So 3 options of upfront payment. The discount now should go up to 72%, and what we observe is 20 to 37% of discount. Yet another option are reserved instances, and those are available for EC2s, DynamoDB, Elasticcache, OpenSearch, and RDS, so multiple AWS services. Here, the commitment is different. You no longer commit that you're going to spend a certain amount of dollars per hour, but instead you commit that you're going to use a particular instance for a period of 1 to 3 years. The reserved instances are bound to either region or availability zone, and if you buy a reserved instance in a particular availability zone, that also reserves you the capacity. So AWS guarantees that for the period of your commitment, that instance is always going to be available in that AZ. And that's especially important if you're running in remote location where the capacity is not always guaranteed. With reserved instances, you get that, but only if you commit to a certain availability zone. With reserved instances, the observed discount for a period of 1 year is 30 to 45%. And the last option are spot instances. Anybody familiar with the concept? Yes. Yeah, sounds good. So, no commitment. You're using the capacity that AWS has underutilized. It's sitting idle in their data centers, and they sell it for a very discounted price. Technically, up to 90%. What we observed is 50 to 65% of discount. But what's the catch with spot instances? Well, the interruptions. So AWS reserves the right to terminate your instance at any point in time, and you have to be prepared for that. What do I mean with that? When you start your instance, you might see an event coming from AWS that's called instance rebalance recommendation. That's a hint from AWS that your instance might be reclaimed at some point in the future. And the rebalance recommendation can come as fast as just you spin the instance. So you spin the instance, it can be instantly followed by the rebalance recommendation. There's no rule for that. Or it can be hours, or it can be days. But that doesn't start the fun. The fun starts when the spot instance interruption warning comes. According to AWS, you have 120 seconds to get your task replaced. And I'm saying it's advertised value because what we normally observed is 123, 124 seconds, but we've also seen some particular cases where that was as low as 15 or 20 seconds. But let's assume we have 2 minutes for now. So what has to happen in that period of time for your task to be replaced? Well, first, it's the ECS scheduler that notices that the task should be replaced. It looks whether you have enough capacity in your cluster or not. So let's assume we do not have an idling instance, but we have to spin up a new virtual machine for that. In our case, the capacity provider that we use is Spot.io. So Spot.io has to talk with EC2, EC2 has to get that instance provisioned, then the operating system has to start, and that process alone can take up to 3 minutes. So if you take a look at that, it means that if your task is running on a spot instance and you do not have another instance capable of accommodating that task, well, you might be out of luck and you might not fit within those 2 minutes. Once the OS is started, the ECS scheduler takes it back and spawns a task on a particular instance. Then the Docker has to start. In our case, JVM has to start because we're running Java-based applications. Then the application has to start. Then the health check has to start passing. And only then can the ECS task be considered replaced. Did we make it or not? What happens if not? If you run a single instance and you do not make it in 120 seconds, you start observing 502, 504 errors. So what did we do to prevent that? Well, we introduced a concept called headroom. So in all of our clusters, we always use some spare capacity. That's sitting idle, just for the sake of interruptions. We are also monitoring the ratio of recommendations versus interruptions. And what we found out, based on the actual data from our systems, is that for every interruption, there is about 2 recommendations. So if anybody is thinking about replacing the task as soon as the rebalance recommendation comes in, well, you might be doing this twice as many times as it's really needed. All right. The next aspect, when it comes to spot instances and providing the capacity in your cluster that is often overlooked, are ENIs. So people often care about CPU and RAM when it comes to scheduling tasks to particular instances. But there's also one caveat. If you're using AWS VPC network mode, so the mode in which the task is provided with a single network interface and IP address, so the same one as if it was running on a regular EC2, there is a number of supported network interfaces that varies based on the instance type. So you might have a case where you have an instance, it has enough CPU, it has enough memory to accommodate another task, another container, but you run out of ENIs and you're out of luck. All right, so the question that you might be asking is, so which instances do we actually use and which purchase option do we use? And the answer is we use all of them. For majority of our workloads, we are using Spot instances. And that was only possible because as soon as the concept of OTP popped up, developers were tasked with the architectural decisions that the applications that they run must be resilient to failures. So they should not treat the application that it can run for a prolonged period of time. It should be capable of handling those interruptions safely. We also use savings plans. We also use on-demand instances. And for our warehouses or the cloud accounts that support the warehouses, where the workloads are the most predictable, we are using reserved instances because we are safe to say that for a period of 1 year, we are not expecting any major shifts in the load. All right, let's talk about the all-time battle, Intel versus AMD. We gather a lot of data, so obviously we were eager to check how those two compare. And we compared them to the base of 5th generation EC2s. And with 6th generation, so the newer one, both Intel and AMD proved to be about 15% faster and cheaper compared to the 5th generation of instances. With 7th generation, things start to get more interesting because Intel is about 15% faster and 5 to 10% cheaper, but when it comes to AMD, it's 50% faster, so much more, but it's also 30% more expensive. So the price to performance ratio has to be checked for each individual instance generation, instance family, and particular instance type. And when I said that we measure a lot of data, I really mean that we do. For all of our clusters and for all of our applications, we are measuring how the underlying instance affects the application startup time, which you already should know that is crucial for us because we're running with Spot instances. And between the first and the last item on this particular screen, if you look at this column, so the average startup time, it can differ as much as between 22 and 39 seconds. So almost the slowest one takes almost twice the time that the fastest one. And the question that you might have right now is, so why are we using the slow instances? And the answer to that is capacity. When you're running with Spot and you want to accommodate the majority of your load to Spot instances, you have to have enough Spot capacity. And in order to have the most Spot capacity available, you need to let AWS and, in our case, Spot.io, choose from the widest possible fleet of underlying instances. So it's kind of a heuristic that we use, and our application teams do not have any influence on which instance they will land on. So they have to be prepared for the worst case scenario, but they can also land on the best case scenario, right? That was one of the decisions that was baked very early into the OTP. And for now, it worked quite well. The last aspect that I want to mention are burstable instances. Anybody familiar with T family of instances? Okay, one person. All right. So as shown in the screen, majority of workloads look exactly like in this particular screen. So there is some average utilization and there are some spikes. For example, Black Friday, huge spike, right? But for most of the time, they are revolving around an average CPU usage. And AWS came up with burstable instance family, which supports exactly that. As long as you're staying around the average or the baseline utilization per vCPU, you're paying less amount of money for that. But if you go over that limit for a prolonged period of time, you have to pay for credits or you are throttled. Sounds complicated, so let's take a look at the example. Let's take the C5 large, so the example that I already shared with you, 9.5 cents for an instance with 2 vCPUs and 4 gigs of RAM. If you find a comparable burstable instance, T3 medium, it costs 4.5 cents. So 5 cents less per each hour. Quite a lot, right? But for every time that you reach over the limit, you're gonna pay 5 cents per vCPU per hour if you're using Linux, and even more if you use Windows-based instances. And what's the baseline utilization? Well, for T3 medium, that's 20%. So if you're averaging over 20%, you're paying for the credits. So if your average CPU utilization for this particular case is at 63.4, you're breaking even. So you're paying for the T3 medium the same amount of money you would be paying for C5 large. But if you are in a bad luck and you're using your instance over about 100%, the T3 instance is going to cost you 52% more than the C5 large, so the non-burstable instance. This aspect, often overlooked, we learned it the hard way. So it's better to not to learn on somebody else's mistakes. And to sum it up, our runtime journey. Over the last 3 years, we've been able to achieve a 61% cost decrease. At this time, we were growing. We were not disabling services. We were adding more services, and at the same time, we were able to achieve this type of cost decrease, thanks to all of the items and many more that I just shared with you.
Maciej basically told you about architecture in AWS, runtime in AWS, and AWS Edge. But this is all AWS infrastructure, let's say. Here in Ocado, we have multiple warehouses. And there, in the warehouses, we have multiple devices. They have to work locally. And we call them the edge. In the architecture diagram, the edge is located here. We use two technology stacks, and actually where this edge is located, anywhere in the world. We just need the internet. Our devices connected to the internet connect to AWS services. So let me tell you our story with cost reduction. Around 4 years ago, we were tasked on how to run workload in warehouses. We had to run applications on some remote devices. By the time we looked at AWS portfolio, there were many technologies, but not all of them were mature enough or were pricey, etc. Also, we already were using normal ECS in the cloud. ECS Anywhere was getting more and more popular by then. So basically, we decided to go with it, to try with it. We started running our workload in the warehouses using ECS, and what basically it gave us. We were able to run containerized workload on any devices supporting Docker. We were able to run and execute remote commands and still have remote access to all of the devices. But there was one problem. The idea of always connected devices. What does it mean? It meant that if one station, one device in our warehouse was down, it was causing ECS to get stuck. And that was a problem. And another problem is the pricing. This is even bigger problem. Why? Because currently ECS Anywhere with SSM Advanced Tier costs us around $12. $12 per month per device. Okay, some of you may say it's not big, it's not expensive. Maybe for the servers. Our edge devices are small devices. We don't have big beefy servers which cost $1,000. So if you take a smaller device which costs around less than $1,000 and you have to pay for each device extra $12 per month, this is expensive. So basically, this service stack was not a super fit for us and it was expensive. But we had to start with something. Around 2 years later, we decided to go back and look at AWS portfolio again to see if there is any better technology, better suited and less expensive. And we looked at IoT and IoT Greengrass. Version 2 of Greengrass was getting more and more mature by then, so we decided to try with it. With the new technology stack, we retain all our requirements, and we had some extras. Until now, we used fiber only. So basically, we had to have stable internet connection to those devices. With IoT and Greengrass, that's no longer the case. We can use wireless connectivity. We can use 3G, 4G, 5G. Why? Because IoT uses MQTT protocol to transport. It does not need super big extra fiber, etc. Also, with new technology stack, devices may become offline. They will not block anything, they will not affect any other devices. There's another advantage of new stack. We can run basically any workload on devices. Why? Because we no longer need Docker daemon, and we no longer need to containerize our applications. With this technology stack, we also have the ability to file transfer to the remote devices and still have remote access. And now the best part. The best part is the costs. Let's say we are under 20 cents for the standard device, maybe about $1 for very talk-active devices. So this looked like a perfect fit for us. Let's compare the two technologies, and that's the software only. So we basically moved from $12.30 to $1 per device per month. So this is huge, and this is software only, as I mentioned. But the edge is not only software. You also need to think about hardware. And when it comes to hardware, when we use ECS Anywhere, we had to use mini PCs. Something like this. This is bigger device. It's standard mini PC. You can see Intel, Asus has some of them, Dell and Lenovo. So all of these devices had to have Docker daemon installed. Why? Because ECS requires ECS agent to run other workload. Basically, it reserves some resources for itself. So these devices had to be beefy. They need resources not only for applications, but also for our platform. So they were pricier because we had to pay around $500 per device. With IoT and Greengrass, we may use even Raspberries. It's a lot cheaper. Why? Because we no longer need Docker daemon, can run any application, not containerized. So we can buy cheaper devices. Currently, we don't use Raspberry Pis, but we use some industrial alternatives because they are better. And let's say we pay $100 per device. So the difference per device is huge. Let's go back to the place where I told you that we have 13 retailer partners around the world. And we have multiple warehouses. And each warehouse may have a couple hundred of those devices or more. So price cuts, not only on software, but also on hardware here, are huge because of the scale. So that would be all on Edge. Let's look at observability.
All right. Hello again. Please bear with me for the last big section of today's presentation. When we talk about observability, we mean both logs and metrics, and we're going to take a quick look at both of those aspects. When you take a look at the CloudFront logs pricing and you look at the data ingestion price, 57 cents per gigabyte for standard or 28 cents per gigabyte of infrequently accessed logs, that doesn't sound like quite a lot. But yet, over the last couple of months, we've been able to decrease the costs of CloudWatch by 37%. Again, we cannot show the numbers and the actual spending, but the numbers, they add up. The 37%, it's quite a lot. So, to give you an example, let's take a look at the network logs. Previously, we were using CloudWatch logs. And we started thinking, well, CloudWatch actually is pretty expensive in our point of view, so what alternatives can we explore to CloudWatch? Well, the S3 sounded like an obvious choice. The requirements for configuring network logs to be set up in S3 were to have an S3 bucket, check. To have a fluent bit agent with destination set to S3, check. The data could no longer be queried using CloudWatch logs inside, but it has to be queried with Amazon Athena. And we had to configure necessary IAM permissions. And the result of that? Anybody can guess the saving ratio of that? How many percent? 35? 87. Just by changing the destination of the logs. And that includes the additional costs related to S3 API calls, as well as Athena queries. How is that possible? Well, if you compare the two, so the log ingestion price and the data storage price in S3, that's almost 25 times the difference. So even if you calculate that you're making around 720 calls per day if you use a 2-minute polling interval, and that you are going to actually use some queries, that's still a huge number. But we've also made some mistakes along the way. It's not like we're always winning. If you're familiar with AWS Web Application Firewall, you know that the web ACLs provide the logging capability. So what can go wrong with that? Well, at some point in time, we were configuring AWS Security Lake. And due to the mistake in configuration, we started incurring double charges for storing the logs in S3 as well as in Security Lake. And over that period of time, we've also observed some costs related to data transformation charges. And the result of that was that we paid X for WAF and 3.5 times that amount of money for the logs. And let me quote myself from one of the conversations that we had at the time. In any situation where logs are more expensive than the service itself, we should start asking ourselves questions about what went wrong. If there's one thing that you should remember from the section about logs, this is this sentence. Some general rules. First of all, when it comes to logs, be sure to investigate regulatory requirements. They may differ based on the market you operate in. For us, we operate worldwide, and those requirements, they differ. And regulations might influence the level of detail that you have to keep, log retention period, the access methods. Another aspect, do not assume there is just one way for logging. CTO of Amazon once said that "we've always done it this way" is the worst sentence in the history of IT. We've always kept logs in CloudWatch logs. But then we switched to S3 and we saved 87%. So don't assume anything. There's a lot of settings you can adjust. The amount of data collected, log destination, log retrieval methods, log shipper, or you can entirely disable the logs that you don't need or use. All right, let's switch to metrics for now. And let's start with a couple of definitions. These are quite important. So the metric is a particular piece of data that you wish to track over time. Time series is a series of numeric data points of some particular metric over time. Each time series consists of a metric plus one or more dimensions or tags associated with this metric. And the cardinality is the number of possible groupings depending on the dimensions that the metric have. Sounds complicated, so let's take a look at the example. Let's say we want to track a single metric, the total number of HTTP requests. And let's say we want to tag it with 3 values: the status, the method, and the region. So how many time series do we have with this one metric over those 3 dimensions? Well, according to Wikipedia, the status can be one of 63 values. The method, there's 9 HTTP methods. And as of today, there's 36 AWS regions. So if you calculate the total number of possibilities, that gives us more than 20,000 individual time series. And if you look at CloudWatch metrics pricing, here's the catch. The CloudWatch metrics pricing is based on a metric per month. But what AWS refers to as a metric is actually a time series. So if you want to track total number of HTTP requests, and you're in the first tier of usage with the 20,000 time series, or AWS called metrics, that's going to cost you monthly $4,000 if you're on that first tier. But if you're on the higher tier, it's only going to cost you $400. I don't know how about you, but one metric and $400, that's insane amount of money. And the example. We noticed that we were generating a lot of metrics in the CloudWatch console. We started asking ourselves, do we need all of the metrics that we have? We noticed that the CloudWatch agent that is installed in our ECS clusters sends disk-related metrics for all available mount points for each host by default. Thank you, AWS, for the default configuration. And the disk metrics accounted for almost 50% of all metrics that we had. Again, that's quite a huge number. And we noticed that there are metrics for ECS tasks for TMPFS, OverlayFS, and, well, the answer was simple. We didn't need those metrics. So we introduced those. Actually, it's 2 lines of code, not 3. And this can be considered the biggest saving per line of code. If you remember that still uphill on the chart that Roman was showing, that was exactly it. Ignoring file system times that were not needed. Quick note about Amazon Managed Service for Prometheus. Prometheus is getting quite popular right now, and AWS provides a managed service for that. In this managed service, you are charged per the number of samples. So again, continuing the previous example, if you have 20,000 time series, that generates almost 30 million samples per day if you're using 1-minute intervals. If you change the polling interval, that's obviously going to change one way or another. And if you use that in the first tier, that's going to cost you $80, again, for just one metric. So to sum up, AWS Managed Service for Prometheus, it is quite expensive. We had a case where we enabled that for some particular project. We had to disable it within 3 hours. It was that expensive. All right, so some general rules. First of all, you should always carefully choose the metrics that you want to track. Be mindful about the metric cardinality, so the combinations of tags and dimensions applied to that particular metric. When performing metric filtering, consider doing it at the source so that you do not incur sample processing or ingestion charges. Again, do not assume there's just one mechanism for keeping metrics. And there's a lot of settings you can adjust: the amount of data collected, metric destination, metric retrieval, as well as polling interval. Or you can entirely disable the metrics that you don't need or use. And with that, I'm passing the mic to Roman.
Thanks, Maciek, and also thank you, Kasia, for all those great ideas about savings in the runtime, at the edge, networking, and in the observability area. This is the last very short section before we will wrap it up. So some couple words about your AWS accounts. If you work in a platform team, your company most likely not only has some production accounts, but also has some development accounts, maybe some acceptance testing, things like that. So in those accounts, we tend to give people more privileges than we do in production. And with that, there is basically an issue that, I don't know, Jeff might have been working on some side project. He was running his workload on EC2 instance, went on holidays, forgot about it completely. Half year later, we are still paying for that. So basically, it happens to the best of us. And we should definitely look for such things, because it will incur you some constant costs. Regarding the test environments, and especially the development environments, what we've learned in Ocado is that, you don't need to run them all of the time. Most of the time, actually, developers work during the business hours, and there are plenty of tools you can use to turn them off outside of that. So for example, if you run your workloads on the EC2 and you use EC2 auto-scaling group, you can set up some easy cron expression and turn them off. Yeah, so let's talk a bit about those single-purpose accounts. Maybe you have some of them where you basically created an account and you run an experiment and you don't need that anymore. So what you usually do, you will go to AWS and ask for the closure of this account. So the process you will go through is that AWS is going to suspend this account for 90 days. And that's for you. In case you change your mind, you can always recover it. But you will still incur costs for the resources running there. So you should first suspend them. Let's talk a little bit about the account architecture, whether you should go with the multi-account or the single account. It's basically, it depends. However, you should definitely limit the number of accounts you are running, because with the cross-account traffic, there is some additional cost and maybe some extra networking components, private links, things like that you will have to pay for. Next one, let's look at number of AZs that you have running in your account. That's basically because you have to pay extra for multi-AZ traffic. So this is some calculation we've done for ourselves with a simple setup with some basic networking components such as NAT Gateway for egress traffic, Route 53 resolver for DNS, some elastic IPs, interface endpoints. In total, with one AZ, you'll pay $130 per month. If you will go to two AZs, that's going to almost double that. And with the three AZs, it's much more than that. So basically, you will have to ask yourself, how many AZs do I really need? So maybe in the dev accounts, you don't need 3 AZs, maybe you are fine with just 2 or even 1. There is one caveat. With some of the services, AWS forces you to use at least 2. So application load balancers and the RDSs, they require at least 2 for the failover purposes. Right, so I've heard that pizza is coming, so it's time to wrap it up. I guess we've learned quite a lot today, and it's probably hard to wrap your head around all of that. So I thought about just basically gathering all of that knowledge in 4 simple rules you can follow. So the rule number 1 is to turn off what you don't need. Some examples that we've been giving you is about identifying and removing unused resources, for example, KMS keys, which was our case. Next one, you should disable unnecessary logs because those can be quite expensive. You should reduce number of CloudWatch metrics, look at number of dimensions you have in those metrics and the time series. You should also look at your network traffic patterns, looking for some bot traffic, and you definitely don't want to pay for that. You can limit that on WAF. And the last one, consider scaling down to 0 when you don't need something, like with the dev environments. So the rule number 2 is to go through capacity planning and prepay for the services. And there are a couple tools we are using in Ocado. I think that the easiest one, at least for the bigger companies, is the private pricing agreement. So if you pay at least $250,000 per year, go ask your managers whether they are willing to sign it. Next one, think about some predictable workloads patterns. And for those, you can buy reserved instances at a very nice discount. If you want more flexibility than and you don't want like commitment to a particular instance type, there are various savings plans that will give you this. And lastly, for the CloudFront savings, you can always prepay by buying CloudFront bundles. The rule number 3 is about increasing the utilization of what you already have. So some examples that we've given you is about sharing our application load balancers. So previously we've been doing one ALB per single application. Now we have multiple under a single one. There is also a case for the right sizing. So basically, you should match your EC2 instance type to the workload. If you figure out that your application only uses 5% of CPU, maybe it's time to downscale the instance. In a cross-account setup, you should consider not using too many private links, let's say. So in our case, instead of using many of them, we just have one, and that will have Nginx behind to route the traffic to application in that particular account. And the tip number 4, the rule number 4, check for new AWS offering and cheaper tools and services. And I think the best example of that was the one that Kasia gave you earlier about the IoT Greengrass, which was not only cheaper for us, but just basically better suited for the workloads we were running, did not require containerization, gave us MQTT, and was just basically better for single board computers. Another example was the argument whether when you are going with the egress traffic but still remaining in the AWS, whether you should really go through NAT Gateway, or maybe you can establish some VPC endpoint and basically never leave the AWS network and pay less. And the last example, when you are using CloudWatch logs and you notice you pay a lot of that, and especially if you don't query those logs too often, S3 plus Athena is the cheaper alternative to that. Right, guys. Thank you so much for joining us today. I hope you've got some ideas from us. And yeah, I wish you all the best in your savings journey. And now will be the good time for questions.
Wow, I thought it was so comprehensive that you don't even know what to patch in this conversation. But yeah, we have a volunteer.
Yeah, great you left it for the end because I had so many questions on the way. I would just first thing, this cost optimization, let's call it project, is a project within Ocado, so you need to justify it, taking into account, the cost of the development team compared to expected, let's say, cost optimization outcome? Or is it some kind of ongoing work which is a part of, the team responsible for, let's say, product or a solution or a component and so on?
I can say from the edge perspective, it's an ongoing process. You always have to look if something is, if you can do something cheaper, better. For us, it will never end.
Okay, I'm going to add a little bit to that. I would say it's a bit of both, because as I mentioned, looking at the cost and expenses is part of our maturity model. So actually something every single team in Ocado will do monthly. On top of that, we also came up with some let's say, time-based squads that were targeting some of those areas. So if you want to move really fast, it's probably better to establish bunch of commando guys and let them work. That's probably the easiest way. But if you want to have it delivered over the time in a sustainable way, it's probably better to engage normal teams, platform teams.
And is low cloud costs a kind of part of your, let's say, definition of done? Or you have this approach that, okay, we deliver fast, taking into account that it might be expensive solution on the cloud side, and then we'll figure it out how to make it cheap?
I can answer this one. So I would say that at this particular point in time, we have embraced the culture of keeping the costs low, and whenever we are trying to introduce a new service, we are looking at the cost first. So I guess we no longer want to overspend on cloud, although there were times, and those were business decisions mostly, that for a particular scenario, it was cheaper to pay more than to lose a certain period of time to do it better, right? And what we shared with you, to add to that and the previous question, this is a couple of years of history shortened to a 1 hour or 1.5 hour talk. So this has been a long journey. It's not like it was introduced just over the last couple months.
Tell something about AI inference. How much percentage is it taken already? Do you run any LangChain or something on the cloud?
Were you asking about AI?
Yeah, I think it was about the percentage of costs of AI, right, within this whole...
I can take this one. I think what we've noticed, especially in 2025, was increasing traffic coming from bots which were associated with some AI agents, basically. So we definitely see some AI impact in the area.
I have a question because I think that on your compute services you didn't list a Lambda. I guess you have like quite big traffic, yes? So I think most of workloads are cheaper on ECS, but there are any cases you use Lambda or actually like the traffic is so big that you don't use it at all?
All right, thanks. That's a great question. For OTP and the applications that run on OTP, we are not using Lambda. So we are using it in terms of the internal OTP services. And of course, we might revisit that in the future. But for now, this is not the way we do things.